Hello and welcome to Learn Chemistry with Banke. In today's lesson, you will learn how to calculate oxidation numbers. Here are the general rules to follow. Rule number 1. The oxidation number of an element in the free state is 0. An element in its free state is an element that is not combined with another element to form a compound. So the oxidation number of any element in its uncombined form is 0. Rule number 2 says that the algebraic sum of the oxidation numbers of all the atoms in a molecule is 0. For example, this is a polyatomic molecule, tetraoxosulfate 6 acid has 3 different atoms. So if you sum up the oxidation number of each of the atoms in this molecule, the algebraic sum should give us 0. Okay. Rule number 3 says that the algebraic sum of the oxidation numbers in a polyatomic ion is equal to the charge on the ion. So here is an example. So for example, you have this particular ion, let's say sulfite ion. The algebraic sum of all the oxidation numbers is equal to the charge. Here is the charge on the ion. So the algebraic sum of all these oxidation numbers here will be equals to -2. So let's say we have another ion. So the oxidation number of all the ions in here, the algebraic sum of the ions in here will be -1, because the charge on this molecule is -1. It's just one minus, it's carrying one negative electron. Also, the oxidation number of a monoatomic ion is equal to the charge on the ion. This is what that means. So for example, we have ion. The oxidation number of this ion is +2. If it were ion 3 plus ion, it would be +3. That would be the oxidation number. If you have iodine, the oxidation number will be -1. If you have fluorine ion, the oxidation number is -1. Oxygen, oxidation number of oxygen, which is a negative ion here, is -2. Here's rule number 4. Rule number 4 says that in any substance, the more electronegative atom Electronegative atoms are usually non-metals. They have the oxidation number as negative. The oxidation number of electronegative atoms, especially non-metals, is negative, while the less electronegative atoms have positive oxidation numbers. So in group 1A elements like hydrogen, lithium, sodium, potassium, they usually have +1 oxidation number. That's positive oxidation number, right? That's +1 for the group 1A elements, which are alkali metals. Group 2 they are also very electropositive. They are less electronegative too, so they have positive oxidation number. All group 2 elements have +2 as their oxidation number. You know that they will need to attract 2 more electrons to complete their stable octet structure, to achieve stable octet structure. Whereas the electronegative elements in group 7, that's the halogens. These are the halogens. Halogens are in group 7. That's halogens in group 7. Halogens have negative oxidation numbers of -1. Negative oxidation number of -1. These are the halogens. These are the halogens in group 7 here. Fluorine, chlorine, bromine, iodine. These are halogens, and their oxidation number is -1. They have a negative oxidation number. So rule 5 says that the oxidation number of hydrogen in all compounds except metal hydrides is +1. Except metal hydrides is +1. That's the oxidation number of hydrogen in all compounds, except for metal hydrides, is +1. Rule 6 says the oxidation number of oxygen in all compounds except peroxides is -2. So the oxidation number of oxygen in all compounds except in peroxides is -2. So this is a peroxide. You have H2O2. That's hydrogen peroxide. So except for this kind of peroxides, the oxidation number of oxygen is -2 in all compounds. Is that clear? So let's quickly do some worked examples based on the rules we have just studied. Find the oxidation number of chromium in K2Cr2O4. K2Cr2O4. So what's the oxidation number of chromium? So to do this, we say let Cr which is chromium, our unknown, be X. Let it be X. So we say let Cr, which is chromium, be X. And we already know that the oxidation number of elements in group 1 is +1, and the sum of the oxidation numbers, the algebraic sum of all the oxidation numbers of atoms in a molecule or elements within a compound is equal to 0. That's equal to 0, right? Now, so recall that we said our unknown should be represented with X, right? And the oxidation number of elements in group 1 is +1, +1 times 2, this 2 here, yeah, we multiply it by the oxidation number of potassium, which is +1. We don't know for X, 2 times X, that's 2X. Chromium, there are 2 atoms of chromium in the compound, right? And we know that the oxidation number of oxygen, except in peroxides, is -2. So we say -2 times 4, this 4 here, and everything will be equal to 0, right? So this is +1 times 2 is 2 plus 2x plus -8 equals to 0. And we know that minus times plus is minus. So this becomes 2 plus 2x minus 8 equals to 0. So here we have 2 plus 2x minus 8 equals to 0. So we say, then we collect like terms. So when we collect like terms, we have 2x. When +2 comes to the other side, it becomes -2. And when +8 comes to this side, it becomes -8, right? So 2x then equals to -10, because I usually explain to my students that if you are owing somebody 2 naira, that's a negative, and you are owing an additional 8 naira, that's you take owing someone money as negative. And if you have 10 naira, for example, and you pay back 2 naira that you were owing, you'll be left with 8 naira. That is, you have 8 naira. That's positive. So in this case, your answer is not going to be -6. It will be -10, because if you owe 10 naira, if you owe 8 naira, and you paid, you owe 2 naira, and then you owe an additional 8 naira, the total amount you'll be owing will be 10. So that's why this is minus 10 and not minus 6, as some of my students usually make that mistake. The next thing will be to divide both sides by 2. Divide both sides by 2. So let's divide both sides by 2. By 2. Okay. So when we divide both sides by 2, we will have 2x divided by 2 equals to 10 divided by 2. So that's when we divide both sides, we have 5. Therefore, x will be equal to 5. And that's plus 5. Since there is something I've missed here, let me change that. So what we have is 2x equals to minus 10. We don't want to leave out the mathematical sign. Yes, so we divide both sides by 2. So this is divided by 2 here. So x will be 2 year 1, 2 year 5. So x equals to minus 5. The mathematical sign is very important. You must always put it there. So therefore, the oxidation number of chromium in K2CR4 Cr2O4, is it 0407, is minus 5. It's minus 5. It's minus 5. Okay. In the next lesson, I will solve more examples, and I want you to go ahead and like, subscribe, and share to your other student friends so that they can learn. And I'll see you in the next video. Cheers. So in summary, when you follow these general rules, you will be able to calculate oxidation numbers, whether for ions or for compound or for elements within a compound. We've been able to do just one example in this video. I will continue this lesson by working other examples, and you'll be notified once you've subscribed to the channel, and you will get the notification if you hit the notification bell, so that you'll be first to know once the lesson on the other examples is posted. Till then, stay safe. My name is Banke, and I hope you learn. I hope you are able to calculate oxidation numbers after watching this lesson. If you have any questions, please leave them in the comments, and see you in the next lesson. Cheers.